Hello everyone, welcome back to Inain's Forensic Classroom. This is part 2 of a foundational forensic concept series, and today we are going to talk about some really important ideas that every forensic scientist uses every day. So today we are talking about probability, statistics, significance, false positives, false negatives, sensitivity, and specificity. So I know it sounds like a lot, but don't worry, I'll explain everything in a way that's super easy to understand. And by the end of this video, you will finally understand how forensic tests are interpreted in the lab and even in the court. So let's start with the first one, which is probability. So probability is basically how likely is something. How likely is something. So what are the chances that this happened? So in forensics, probability basically means what are the chances that this result happened by coincidence, or how likely is it that this evidence came from someone else. Now, I'll give you an example. Imagine you find a shoe print at a crime scene. Now, if it is a common Nike size 8, thousands of people could leave the same print, right? So the probability that it belongs to someone random is pretty high. Now imagine the same shoes has a rare design or a unique scratch on the sole. So the probability that it matches someone else now becomes extremely low. Now the probability helps forensic scientists understand how weak or strong a piece of evidence is. Moving to the second one, which is significance. So significance basically means, is the result meaningful or is the result important? So see, just because something happens doesn't mean that it matters. Significance tells us whether a result is important or it is just a coincidence. So I'll give you an easy way to understand this. Imagine you buy a lottery ticket, okay, and you win once. So that could happen by chance. Maybe, you just got lucky. Now imagine you buy 10 tickets in a row and you win every single time. So that's highly unlikely by chance, right? You would start thinking like maybe there's something unusual going on. So that is significance when a result is unlikely to happen randomly. In forensic science also, significance works the same way. For example, in a fingerprint, um, a few similar patterns may happen by coincidence, but if you have a full set of patterns which has matching minutiae points, is highly significant. So significance doesn't prove guilt or certainty. It just tells us how strong the evidence is and whether it's likely to be meaningful. That's what makes it important for solving a case or presenting it in court. The third one is statistics. So statistics is basically the backbone of forensic science. It is a tool to understand both probability and significance. So statistics is basically the math and methods we use to calculate probability and to assess the significance. Now, for example, calculating the chance that two DNA samples match. For example, if you say that there is 1 in 20 million chance that this DNA matches to someone else. See, it is not guessing, it is science. Even things like bloodstain patterns, bullet trajectories, handwriting comparisons, they all rely on statistics to understand how strong or reliable the evidence is. Then the fourth one is false positive. So false positive is basically the test says yes, but the reality is no. Now, what a false positive means is the test says something is present when it actually isn't. So imagine a test that supports, that is supposed to detect blood. If it reacts to beetroot juice or ketchup, it shows a positive result even though it's not blood. So that is false positive. False positives can mislead an investigation. So scientists always do confirmatory tests in order to be sure. Then we have something called as false negative. false negatives. So here test says no, but the reality says but the reality is yes. Now false negative is basically the opposite. The test fails to detect something that is actually there. So think of it like this. I tell you to check your pockets for your phone. Okay. Now if you do not find your phone in your pocket, you panic, right? But later on you realize that it was in your bag the whole time. So the phone was there, but your test, like you quickly checked your pockets for the phone, it failed to detect it. So that's exactly what a false negative is in forensic science. A false negative happens when the test says no, but the truth is actually yes. So some simple forensic examples I can give you is, see, if you test for the GSR, which is gunshot residue, and it comes back negative because the suspect has washed their hands. So the particles were there earlier, but the test didn't catch them now. So why is this a problem? False negatives can mislead investigators. It can make them think that there's no evidence, when actually the evidence was destroyed, diluted, washed away, or it was too faint to detect. Now, a false negative is when the evidence exists, but the test fails to find it. Then we move on to sensitivity. So sensitivity is basically how good is the test at detecting small amounts. Now, sensitivity is basically the test ability to detect even tiny amounts of something. For example, a highly sensitive blood test can detect even a tiny trace of blood, maybe just a simple small droplet. If the test isn't very sensitive, it might need a bigger amount to show a positive result, which means it can easily miss the small evidences. And when that happens, we get false negatives. So the test says nothing is there, but actually the evidence was there. Then the last one is specificity. So specificity is basically how good the test is at avoiding mistakes, or how well can the test avoid confusion with other substances. So specificity is the other side of the coin. It tells us how good a test is at not getting confused by other substances. For example, a specific blood test will only react with the real blood, not beetroot juices, ketchup, or any red paint. So if a test has low specificity, it gets confused easily, and that leads to false positives. So the test says that something is there even when it's not. So to wrap everything up in a simple way, every forensic lab in the world is always trying to balance two things, which is sensitivity and specificity. So high sensitivity basically means we don't miss tiny clues, and high specificity means we do not accidentally blame the wrong person. And probability and statistics, they basically helps us explain how reliable our findings are. Not, what just the evidence shows, but how confident we are about it. And that brings us to the end of part 2 of a foundational forensic concept series. Now you understand the science behind how forensic results are interpreted, why tests miss something important, why they sometimes get confused, or how experts decide whether a result is strong enough to be trusted. So once these basics are clear, every branch of forensic science becomes much easier to understand. So when we soon dive into the physics, chemistry, toxicology, and more, you will already have the foundation that you need. So if you found this video helpful, hit the like button, share it with your friends, and don't forget to subscribe to Inain's Forensic Classroom. I'll see you in the next video, and trust me, the journey is about to get even more interesting. Bye.